Thanks. Yeah, if you're feeling tired, just like wave really frantically so that I know, okay? So normally I don't say anything about, already? Really? Normally I don't say anything at all about myself when I give presentations because my concepts, my ideas should stand on their own. But since this is ostensibly about like tech and future and management, and you probably don't know me, so you're thinking, who is this bloke? He's wearing shorts. Why would he be wearing shorts? So last week in the States is a big holiday called Thanksgiving, where family comes in from all over, gets together, big meal. And my brother-in-law was there, and he lives in Alice Springs. So all last week I heard about how dry it is, and it's over 100 degrees Fahrenheit all the time. And so I came away from that convinced that I should not bring any long pants with me. But regardless, we'll get back to Thanksgiving. Who am I? I've been a manager for a very long time. I had the distinct pleasure of being a manager at Netflix for 3 years on the same floor as Brendan. So I will do my best to leave time at the end for questions, and then you can compare and contrast the point of view of an individual contributor, a stunning colleague, senior software engineer, versus a hiring manager at Netflix. But I'll be talking about manufacturing high-performance teams. So looking at ways to make architectural decisions as well as the equivalent from a management point of view to make your teams high-performant teams. And again, I think this qualifies for like a credential check. So I'll just give you an example. I managed 2 teams while I was at Netflix, which even at Netflix is rare. But one of them was the traffic team, which when I joined was had a reputation for being highly cynical, difficult to work with. It was kind of a pariah within Netflix. And when I left in 2017, they had pulled off the most celebrated internal technical achievement of that year, 6-minute regional failover. The other team I managed was the chaos engineering team, which when I started at Netflix, I was hired to manage the traffic team. And about a week into being on the job, my boss left. So my new boss, his old boss, is now my boss, said, well, he created a charter for this chaos team, but we don't have anybody to lead it. Does anybody want it? And I was new, so I didn't know any better. Everybody else took a step back, and I was like, well, what's, and he said, oh, Casey, great, okay, you can have it. So I haphazardly ended up with the chaos team, which means I had to figure out what they do, define that, create that, and I made that team internationally famous. We wrote a book, we defined what chaos engineering is. If you've heard of chaos engineering, it's probably because of work that I've done with that team. So I managed those teams simultaneously for 3 years. I would consider them high performance teams. Those are pretty laudable goals. What is a high performance team? I think this is a know it when you see it kind of situation, but if you want a more formal definition, I would say one that meets or exceeds expectations for fulfilling business goals. And obviously you can say like, there's some median there, and above that would be high performing and below that would be low performing. But I'm perfectly happy with you just having an intuition for what high performance teams means. So how do we manufacture high performance? Brendan put up a similar picture of the architecture of Netflix. This is very complicated. Why would Netflix do this to itself? This is microservice architecture. Why would you do that? Well, most companies, when they make explicit optimization decisions, like explicit, like written down, they optimize for one of these 3 things: performance, availability, or fault tolerance. The difference between the latter 2, like an online game wants availability, they don't particularly care about fault tolerance. A bank wants fault tolerance, they don't particularly care about availability. And Netflix explicitly said, we want to optimize for a 4th property simultaneously. More experienced teams can optimize for all 3 simultaneously. Netflix wanted to optimize for a 4th one simultaneously, which is feature velocity. So they explicitly made an architectural decision, microservice architecture, to improve their feature velocity. Because by decoupling the rate at which they push to production, and by having smaller teams, they were able to deliver features faster. Okay? Now, at most companies, if you wanted to optimize feature velocity, what would they say? They would say, well, let's change our process somehow. Let's move to Scrum or Agile, or bring some consultants in and figure out what's making engineers slow. This works better, making engineering type decisions that improve your feature velocity. So I want to tell you a little bit about the field that you work in. The chief merit of software engineering is its technical efficiency, with a premium placed on precision, speed, expert control, continuity, discretion, and optimal returns on input. Sounds pretty good, right? I put software engineering there in red in brackets because I accidentally did this. This is the real quote. The chief merit of bureaucracy is these things. In sociology, particularly ethnographic circles, they define software engineering as, or they classify it as the bureaucratic profession. Why are they so mean? Why would they say such a thing? Because no other industry has done a better job of separating who decides what needs to be done from who decides what to do it, who decides how to do it, and the people who actually do it. So it's good to know that most of our industry looks like this. It is purposefully structured as a bureaucracy. That works fine for simple projects. The software world is moving into an era where most of what we work on are complex projects. This doesn't work so well, but we'll explore that. So how do we manufacture high performance? Let me give you another example. Netflix created this thing called Chaos Monkey. How did they come up with it? Well, what is Chaos Monkey? So Chaos Monkey will pseudo-randomly pick instances in its cloud deployment, and during business hours, turn them off, at least once a day per service. Why would you do that? Well, they did this for a bunch of reasons. They moved from a data center to a cloud deployment, which means they went from vertically scaled to being horizontally scaled, which means they now had thousands of instances, and a feature of the cloud is that instances will sometimes just disappear. And so in the initial months of that transition, they had outages and other problems due to single points of failure, suddenly making themselves known when the instance disappeared. So they tried a lot of things. This was not like something that they sat around and just thought up of. They tried a lot of things. This is one that happened to work. They created something to proactively turn instances off. And here's the thing. When you take the problem that you need to be solved and put it directly in front of engineers, turns out they're pretty good at solving it. So Netflix is easier to think of. It doesn't really have one engineering organization. It has, like, say, 100 engineering teams, 5 to 7 people each. And it doesn't have a CTO or a VP of engineering who can dictate, you shall all make your services highly available, and you shall do it this way. You shall have, you should be in 3 AZs, and you should all use Hystrix, and we could list out 12, I don't know, at least a dozen best practices for creating reliable services that would not be affected by a single point of failure disappearing. Netflix has no mechanism to do that. So instead, they found a way to take the problem, put it in front of the engineers, and they couldn't get their jobs done that week until they solved this problem. And once they did, then they never had to think about this anymore. And many, many years went by with them not having an outage due to a single point of failure disappearing. So we figured out, well, there's something good going on there. We formally defined chaos engineering. Here's the cool formal definition: the facilitation of experiments to uncover systemic weaknesses. And we published a manifesto of sorts. Principlesofchaos.org is where you can find that. But we figured out that there's something else that's happening here. This is a model from Rasmussen. I'm a fan of mental models. So one of the things that engineers in particular are guided by are 3 boundaries. an economic, workload, and safety boundary. Now, economic, we all understand if we run out of money, you're not going to have a job, right? And generally, you probably have a sense of how well your company's doing. We all understand that if our workload gets too hard, we're going to burn out. We're going to fail. Same for resources, right? Like if they're pushed too hard, they're not going to work. And we all generally kind of have an idea of where the workload boundary is. And then there's safety. If we're not safe, if we don't have security or availability stuff in place, then there's a boundary over which if we cross it, we're not going to survive. Here's the interesting thing. Almost none of you work in a situation where you have an intuitive sense of the safety of your system. How do I know that? Because outages continue to happen all the time. And if you knew that your system was vulnerable to that kind of outage, you would just fix it before the outage happens. So what chaos engineering actually does is it creates a signal for the safety of the system that then the engineers can intuitively know where that boundary is. And so then they stop subconsciously moving away from the boundary of economics and workload because nobody wants to fall over those lines. And they can center themselves better. So it's a form of better context. So how do we manufacture high performance? Long quote, but worthwhile. The requirements for design conflict and cannot be reconciled. All designs for, let's say, software are in some degree failures because they are compromises, and compromises imply a degree of failure. It's impossible for any design to be the logical outcome of the requirements simply because the requirements being in conflict, their logical outcome is an impossibility. Forgive me if this was already polled. How many of you are actually CTOs? How many of you are CEOs? Engineering management? Okay, cool. So I'm reminding you of something that, how many of you were engineers before you were in management? Ah, cool. Maybe you didn't know this about yourself when you were an engineer, but this is important to keep in mind, particularly when you're thinking about how to set up the right circumstances for a high-performing team. There is no right design. Engineers are constantly navigating a shifting landscape of conflicting requirements. And that changes minute to minute. As a manager, you come in and tell them, oh my God, we had an outage, now we're in the news, and like the CEO is gonna pour hot lava on us. Like that completely changes how they write their code because they have a different signal of what to optimize for as they're going about doing their day. So how do we manufacture high performance? My job at Netflix as a manager was to flip the bureaucracy on its head. And instead of somebody telling the engineers, you will do stuff this way, I need the engineer to tell me how they're going to do their job, how they're going to solve the problem. So the CTO should know what the company needs. The CTO should know, okay, from that, here are the tech problems the company needs to solve to get the company what it needs. And then there's ... some long chain of management that apparently most of you are in. What tech problems the your org or your team needs to solve to satisfy the CTO's needs. And eventually you get to the person on the front lines, the sharp end, as we call it. What tech problems do I need to solve? So my job as a manager was to make sure that everyone on my team understood this whole arc so that they could comfortably answer this question. Am I confident that what I'm working on right now is the most important thing that I can be working on for my company? If they can connect the dots from what they're doing right at this moment to what the company needs, then basically I can disappear. And wouldn't you love to just be able to disappear and have your team still do great? How do we manufacture high performance? Let me give you another example of manufacturing. So one thing, we need to be correct about the things that teams need to solve. And this is a great counterexample of what I often hear. I ran into this a lot in my career, where engineers would say, well, we need to make this simpler, or an architect. Yeah, usually it's an architect, not an engineer. We need to make this simpler. That's not an actual business problem. That's a symptom of other things wrong with engineering. Probably them not having the right problem in front of them. And let me give you an example of why that's true. So there's two categories of complexity, or we can bucket complexity in two different things. One is accidental, and the other is essential. Accidental is like dirt on your floor in your house. You don't put it there on purpose, it just happens because life. I actually have 2 boys under 5, so they sometimes bring it in on purpose. But assuming you don't have that, dirt just happens, right? Accidental complexity happens just from the fact of writing code. You write code, you create complexity. And here's the important part. There's no known sustainable process of simplifying code. You can stop and simplify code in like break time or something else, sprint, a few sprints. And you can, in theory, TDD and other practices like that will maintain a level of simplicity. But theory never lives up to the practice. And so, and while you're simplifying code, you're not satisfying new business requirements, right? So there's no sustainable way to reduce accidental complexity. There's also essential complexity. Here's the stuff you add on purpose because it's a business requirement. You have to make things more complex because we live in a complex world and we're building control systems. So by the law of increasing requisite variety, the software world is always going to get more complex. At the end of the day, what does this mean? It means complexity is always going to increase. So if you're trying to reduce it, you're probably not doing the right thing. Let me give you an example. Imagine that I have a key value database on this very high-tech laptop. Isn't it? It's a high-tech looking laptop, right? In memory, you give it a key and value, it stores the value. You give it just the key, it spits the value back, right? Super simple. And I tell you, you know what? I want you to make this really highly available. All right, first thing we can do, we can put it in the cloud, right? That way when I close the laptop lid, the database doesn't disappear. What else can we do to make it more available? Well, we can put it behind a consistent hash ring so that multiple servers have different, store different data and they replicate it. What else can we do? We can replicate the hash rings to multiple data centers. This is you can get this in off-the-shelf KV store stuff, right? Like this isn't hard to do, but in less than 30 seconds, like I've described an architecture for making an extremely high available key value store. Let's go back to our simple one. Now, what if I said, I want you to make this more available and simpler? Go. You can't do it because the business requirement is to make it more available, and that requires adding complexity. So accept that. Your world's going to get more complex. Your team has to solve complex problems. Don't try to simplify things. If you hear people say things like, we need to make this simpler, that's not a real problem. A high-performance team is going to reject that kind of guidance. So how do we manufacture high-performance teams? Here's a theory taken from manufacturing. Economic pillars of complexity has 4 parts, 4 components: states, relationships, environment, and reversibility. The quintessential example here is Ford in the 1930s, Model T. You can have whatever kind of car you want as long as it's black and a Model T. So they simplified the states. You can only have one kind of car. All the parts were standardized. They simplified the relationships because they implemented Taylorism to a T, right? So other car companies had teams that built a car. At Ford, you could only maybe talk to the person to your right, not to the person to your left. So the relationships between the manufacturing process were limited. Environment, nobody can control that. And reversibility is basically impossible when manufacturing cars. I'm not talking about putting it in reverse, obviously. Software. Business requirements are going to push you to increase states. relationships are constantly increasing because we're moving to things like microservice architectures and huge dependency graphs. Environment nobody can control, but reversibility. This is where software stands out. Going back to the movement to Agile, or XP really, from waterfall design, where you spend a year speccing something out, designing it, put it in front of a customer, and they go, no, that's not right. Well, can't change that decision, so just keep plowing forward with the wrong thing. To, in principle, XP or Agile, say a week-long sprint, get something in front of the customer, no, that's not right. Okay, second week, yeah, that's closer, and by third week, you're on track. That was a way of manufacturing a better reversibility in software. Now, CI/CD, asynchronous deployments, containers. These are all things that improve the reversibility of the decisions that you make. Good source control. Canaries. So if you're in a position where you can make architectural decisions that allow your team to make more reversible decisions as engineers, then you're doing them a favor. You're allowing them to navigate complexity better rather than trying to get them to reduce complexity, which is just a fool's errand. Kitchen model of organization. Here's a different mental model to think about how you might want to manage a team, a high-performance team. Think of a well-run kitchen. So back to Thanksgiving. I don't know what the Australian equivalent is of Thanksgiving. Is there one? Well, hopefully you've had the experience where family all comes together and makes a meal, and then you eat it. And it just happens, right? Nobody sits there and goes, okay, lift up the knife, push the celery forward, put the knife down, lift up the knife, push the celery forward. People are in the kitchen and dinner just happens. And hopefully, if you've been on the cooking side of that, you've had the experience where you finish what you're working on and you're done and you stop and you look around and all of a sudden you're in everyone's way. Why is that? It's because over millions of years, we've done a very good job of developing a theory of mind, a subconscious ability to model other people's behavior based on understanding their goal. And the moment I don't have a goal, nobody else has a model for what the hell I'm doing there. And so I become an obstacle. So if everybody understands their own goal and the goal of the rest of their teammate and ... up to the CEO and what the company's trying to achieve, then without telling them what to do, if they're competent, they'll just do it. And as a manager, that makes your life a hell of a lot easier. So what can you do for the kitchen model of organization? Embrace complexity, navigate it, don't try to limit it. You provide opportunities for teams to practice working together, which is not training. This is practice. Training is like this. Everybody sits down and somebody talks at them. That's no fun. Tolerate inefficiencies. This is one of my favorite because I hear this a lot too. We need to make this code more efficient. That's not a business goal. And efficient code, efficient anything, is brittle. So if you want a system that's reliable, resilient, then you want it to be inefficient. I love the counterintuitive stuff. And communicate the margins. How close are they to running out of money? Hopefully that's not a panicky subject. How close are they to overrunning their workload? And how close are they to overrunning the safety margins? And I'm going to venture that this following is going to be the most important message that you'll hear at this conference. And unintentionally, this is going to make some of you uncomfortable. But I don't know a way to talk about this without making some of you uncomfortable. So let's just smile, and then maybe it won't be too uncomfortable. 2019 is the year that Silicon Valley wakes up to diversity and inclusion. I'm on the board of some companies, and so I like to see who they hire. And I noticed that a few of them are based in Australia, and I noticed that there's a bit of a disparity in the groups that get preferentially hired, particularly in Australia compared to the US. And it's not good in the US. Why do we care about diversity and inclusion, particularly when you're manufacturing a high-performance team? Well, diversity and inclusion, what is it? It's a competitive advantage. Turns out that skill does not discriminate by gender or race or any of the other underrepresented groups. So if you work at a company, a tech company, software engineering company, that is all or mostly men, that means that you've excluded a huge portion of the talent pool in a system that is highly competitive for talent. So if you have a diverse team, then it almost ensures that you're doing a better job of having a better talent pool. It gives you a competitive advantage. It is also not the responsibility of HR. This is not a compliance thing, and it's not a pipeline problem. It's hard work right now, but hard work is hard because it has a bigger payoff. So if I told you that in whatever domain you're working in, that I know a group of really talented engineers, if you take your job seriously, you would ask me, oh, how can I get in touch with them? There's a lot of talent in underrepresented groups that is currently untapped. So it is if you take your job seriously, it is your responsibility to get in touch with them. That's the hard work part. It's the responsibility of leadership. Again, not HR. This isn't a compliance thing. This isn't a meritocracy thing. That's horse. I don't know how well you take colorful language at conferences in Australia, so I'll bite my tongue. But it's the responsibility of leadership. If it's difficult for you to retain underrepresented groups in your company, then as leadership, particularly top leadership, CTOs, that's because you're allowing a culture that discriminates against those underrepresented groups. Brendan was talking about brilliant jerks. Well, for underrepresented groups, there's a whole other slew of behaviors that can discourage underrepresented groups from sticking around. And that starts at the top. It's a sign of competence. Those of you who want to do business in the States or who are doing business in the States, you're going to see more scrutiny over this. What is the makeup of your company? Because if you have a diverse company, then that's immediately a sign to me that you're more competent than most of the software engineering companies that I deal with. Because it's a testament to your prowess as a manager. Oh, and morally, it's the right thing to do. How do you get started? Really easy place to get started. This is a really quick book. Comes from the dean of gender studies at Harvard. It's really short. A lot of low-hanging fruit in there, like how do you change your interviewing structure to improve your diversity and inclusion. So I'll leave you with that. Individual contributors don't create high-performance teams. It's not the ICs, all right? If you come up to me afterwards and say, oh, but I've got a bunch of low performers, they're all cynical. My traffic team was low performing and cynical when I got there. It's not them, almost always. High performance teams are created by management.